Matan introduced me. My name is Boaz Ziniman. I'm a technical evangelist with the AWS team here in Israel. And we're going to talk today about serverless architectural patterns. And I would like to show you some patterns our customers are using to run their serverless applications. We're going to focus on two patterns. I'm going to mention a few others. But I want to start my talk and talk about serverless beyond Lambda. And during the sessions this morning, most of the people spoke about Lambda in many of the sessions as one of the main vehicles of serverless. And yeah, we need to give this to Lambda. When Lambda was introduced, it's basically what started this entire trend of serverless. But serverless is much more than Lambda. And there are many other services we're providing today on top of our platform that are serverless in nature. So they might be not 100% compatible with the idea of serverless, or some of them have some cost, even if you're not using them. Some of them you need to scale them manually, or at least to define some throughput, like DynamoDB, or define shards for your Kinesis streams, but you're not running servers with those services, and this is what I want to talk about. How do we take this entire concept of serverless and take it beyond Lambda, when Lambda is a very important part of your solution, but not the only part? And the first pattern I want to talk about is the web application and microservices, and this pattern is very close to me personally. I'm coming from a very long background of 20 years of web development, and I was in the crowd at reInvent 2014 when Werner went on stage and introduced Lambda. And 20 seconds later, I was thinking only about one thing: how my life as a developer in these 15 years before Lambda was introduced were looking different if I had this tool 10 or 15 years ago. How do my web applications, large scale, small scale, tiny internal tools would be designed completely differently if I had these capabilities of serverless code running based on events or based on API calls? So web application and microservices API, call it whatever you want, is a very popular use case among many of our customers. This is the basic setup. I think you saw it more than once. On the top level, we have our static content. It is based on Amazon S3 and Amazon CloudFront to distribute your content with our CDN network. And basically, you can use today S3 to store your static content, your HTML files, your images, your CSS, JavaScripts, documents, videos, media files, whatever you want. And if you're not aware of this feature of S3 that allow you to store your entire website, entire static website on top of S3, this is something you really need to check, because this is the easiest and cheapest way to run websites today that are static. But most of websites today are not static. There are some landing pages, and even then you have to track them and send statistics. So we want to add some dynamic capabilities, some logic to those pages, and this is what I have on the lower level. So I'm getting it with using Amazon API Gateway, which basically is being called by JavaScript for my static page. So if I need to show now a product catalog, I will load the HTML, the static HTML page, will load my JavaScript, and using a simple JavaScript call, will call API Gateway that will invocate a Lambda function, will query some kind of a storage. In this case, I'm using DynamoDB, but you can use other types of storage. You can use S3 for storage. You can use relational databases. It's not serverless anymore, but still using RDS as a service, and get this information about my product catalog, return it in some kind of format that is easy to parse by JavaScript like JSON, and display the product catalog with the images and everything else on top of your web page. And this is something very, very common. And of course, API Gateway can invocate a single Lambda function, can invocate multiple Lambda functions, and you have a lot of things you can do with it and play with it to achieve websites. There is one piece missing here, and this is user management. And you can do user management on your own, but if you want to use a service for that, I really suggest you check Amazon Cognito for your user management requirements. And I'm going to talk about Cognito in more details in a few slides. So this is the basic setup. And how do I protect this setup? So there are a lot of tools that you need to take into account when thinking about how to create security around something like that. First of all, on the top level, we have Amazon S3 that you can control your buckets, your basic storage, and decide if it's public or private. take into account if you're setting something for public, anybody can access it from anywhere in the world. You can have fine-grained security definitions using bucket policies and ACLs. You can even define that your entire setup, all your buckets are private and only expose them through Amazon CloudFront, the CDN. So basically, only the CDN can access the origin and then serve it to the customers around the world. On top of CDN, of CloudFront, you can have some very interesting features like geo-restriction that is heavily used by customers that needs to do some copyright management to make sure that content is accessed from one location, is not available in another location. You can have your signed cookies inside URLs to provide gated content. So you can integrate it with your Lambda function and basically provide the customer with a signed URL that only this URL can access a specific type of content. And of course, CloudFront can use as your front-end protection for DDoS and other types of attacks to make sure that your application is still working and provide the service needed to your customers. So this is the top level, and let's talk about the bottom level. So on the level of our services, like DynamoDB and Lambda, we're using IAM, Identity and Access Management, to define who can access which information, who can invoke this Lambda function. I can basically define a policy for my DynamoDB saying that only a specific function can write to this DynamoDB, and a different function can read from this DynamoDB, and basically create a situation when I'm giving each function only the needed permissions to perform its job. And this is according to the idea of the least privilege security policy, and I can get it by using IAM. On the level of Amazon API Gateway, you can get a lot of features and tools like throttling to prevent flooding of your API or making sure that customers are not using it beyond a certain level. You can have caching. You can have usage plans if you want to monetize your APIs and basically sell a different usage plan to different customers. And of course, you can integrate Amazon Certificate Manager to allow you to provide your own domains on top of API Gateway with SSL and fully secured. So this is the basic protection schema for such an application. And I said before that we can manage our users with Amazon Cognito. Let's talk a bit about Amazon Cognito and what it can provide you and what can you do regards authentication of the users accessing your APIs. So you have several ways to protect your API calls or to authenticate your API calls. And you can use IAM, which is a very basic way to define roles in IAM with certain permissions. More common is to use one of the two methods here in the middle, the custom authorizers with Lambda and Cognito. So using Lambda, you can basically invoke a Lambda function each time there is a call to your API and create your own logic to authorize your users. It can query any database. It can query your own internal database. It can query Cognito as well and basically return a token or something else to the customer and then being used for authentication. There is a very simple way to define caching for that, so you don't need to invoke this Lambda for every call. You can decide you're doing it once every 5 minutes or even once every 24 hours. This is enough for your security. And this is one way to do it. You need to write your own code. You need to write your own authorizers. The easiest way to do it, and if you're starting a new project on Lambda and building your serverless solution and need to manage users, I would really think you should check Cognito user pools. And this is the easiest and simple way to integrate users into your system, including everything you need around it. The registration process and the confirmation email and the login page, and you can customize each one of them and basically send everything through Cognito user pools. You can connect it to OpenID and to SAML solutions, so you can have your Facebook or Twitter login integrated into that and basically have this integrated really easily. It's just a few clicks of a button in API Gateway to integrate Cognito into this process. So this is what you're getting from Cognito and Amazon Lambda. There are two types of information that is passed to the user, or two ways to authenticate the user. One is by token only. So this is one way, and the other way that we introduced recently is by the entire request. So you can have additional fields inside the request to authenticate the user or to put it in a specific group and then provide different content or different level of access to your different APIs or to your different Lambda functions because it can take this information coming from the request and pass it to the Lambda function, and then use additional logic on the level of Lambda to do another way of putting users into different groups or something similar. So, as I said, very common, very popular between a lot of our users. And another very interesting feature you can do today, and it's relatively new, is to have multi-region API gateway, and basically create your API endpoint close to your customers. So this was something that was not possible at the first days of API Gateway. API Gateway was exposed using CloudFront, and there was only one endpoint. It was distributed, but it was only one endpoint at the end of the day. Today, you can have your own regional API gateways, and you can create rules using Route 53 to route calls to these regional gateways based on latency or based on geographical location or anything like that. And of course, you can use SSL to secure each one of them and have a single SSL for multi-region API gateways. Once again, this is a relatively new feature, so it can allow you to build systems that are more customer-oriented in terms of performance. So you can have your Lambda functions and your API gateways on the East Coast, on the West Coast, in Europe, and route your customers to the nearest endpoint to give them the best performance, or sometimes give them a different service as well, depending on the use case. If you want to try something like that, there is a nice blog post and a GitHub repository that basically takes an online store and creates a serverless online store. So you can read the blog post, you can download the code and try it yourself, deploy it in your environment, and basically see how you can create an entire project of an online store with the product catalog and the check-in and check-out and the cart and everything else, using serverless, no servers whatsoever. So this is the first pattern, and I want to move to the next one and talk about stream processing. And I think this is one of the most popular patterns we see today using Lambda and using other tools. Kinesis, of course, we're going to talk a lot about Kinesis, and actually it was mentioned a lot this morning. And I want to talk about a few things that are setting up the definition of what is streaming. So first of all, you have a very high ingest rate. You're getting data from a lot of sources, and you're getting data very, very frequently. And you need something that is near real-time processing from ingest to process. And if you're talking about a solution that few hours is good enough, or maybe even few days, there are other solutions for that. This is not streaming. We're talking about things that the time between ingest and processing goes between few seconds to maybe few minutes. And this is something you need to do really, really fast on large amount of data. The other thing is the spiky traffic. You can have spikes based on the time of the day, seasonal spikes, unpredictable spikes. And this is something that very characteristic for streams. And you want to get two things out of your processing design, and this is durability, not to lose records. And the other thing is keep the ordering. It's not true all the time, but sometimes you want to keep ordering. And usually when you're designing distributed systems, getting both durability and ordering from the same system is something very, very challenging. And I'm going to talk about at least one case when we provide some kind of a best practice how to actually do that. So the Kinesis platform can help you to manage something like that. And with the years since we introduced Kinesis, we are providing more and more features and new functionality into Kinesis. And this is one of the basic use cases. In this case, we're talking about Kinesis Firehose. And the idea of Kinesis Firehose is to take data from multiple resources and stream it somewhere else. And this somewhere else can be different AWS services. You can stream to AWS S3 as buffered files. Buffered files means that you're not streaming every request that you're getting. You don't want to deal with millions of tiny files of few bits, and you want to take and put them into a buffer. So you're saving, let's say, every 100K or every mega or giga or every 1 million requests. Depends on your use case. You can stream it into Amazon Redshift and basically run any SQL query on top of this information. This is another solution. And you can stream into Elasticsearch services and then use all the capabilities of Elasticsearch, including Kibana dashboards, queries, and other features that are coming with this platform. And it's usually something that you do in a click of a button. You say, defining from one side, this is my stream source, this is my destination, fire up, and it works. On top of that, you can invocate a Lambda function that will do manipulations and enrichment to the incoming streams. So for example, if you have information stored in DynamoDB, in a lookup table with some additional information about your streams, you can invocate a Lambda function that will query DynamoDB, get this additional information, add it to the stream, and send it to Firehose, and from there, you can store it to any one of the destinations. Take into account that when you have transformed records, you're basically losing your original record. So in case you need to roll back and do some analysis on the raw records, we really recommend that in this case, you're going to store on S3 the source records backup as well. And if you say this is a bit of an overhead and I'm storing a lot of things that I might want to use ever, there are very simple rules you can define for data retention on top of S3. So you can define that after a week, you're going to a lower level of storage, and after a month, you're deleting it or sending it automatically to Glacier for archiving, and basically create a pipeline of data that even the source records, you have a backup, you can go to this backup anytime, and automatically it will disappear from the system, and you stop paying for it using some very basic lifecycle rules inside S3. So, few best practices when you're working with streams. So we've been talking about Firehose buffer size. So please take into account that when you're increasing the buffer size, you're invocating less Lambda functions. From one hand, it's great because less Lambda function invocation is probably going to save some money. In some cases, the size of the buffer can be so big that Lambda function won't be able to process it, or it will take a lot of time to process it. So you need to play with this number of buffer size when you're designing your system. Of course, the larger the buffer size, you get fewer S3 put calls, so you're saving some money on that as well. And with streams, we're talking about a lot of information, so this can be really important. Enable compression to reduce the storage cost. And of course, we spoke about it already, but enable source record backup in case you're doing manipulations using Lambda on your original stream. If you are saving data into Redshift, follow this link. I'm going to share my slides, and I'm sure Adam is going to send the link to it, and if not, just follow my Twitter. Read this information about how to use it correctly, how to store this information, the best practices regarding storing this information inside Redshift. Now, I want to do a short demo and experiment, and for that, I'm going to need your phones, please. So please take out your phones. We're going to do some streaming live. There is a QR code on this page. And if you can't read the QR code, there is a URL, but just pay attention to the capital letters in the URL. I'm going to switch here. And basically what we're going to do is play two games. Okay, cool. Ah, you started already. I didn't even tell you the rules. So we're going to play a streaming game. We're going to stream some data from your mobile phones into AWS IoT. And the first game we're going to play, we're going to choose our favorite color. So what I'm asking you right now, I'm going to give you a few more seconds to scan. You need to scan the code, or you got it? There is the URL here as well, by the way. So, what? Want to scan the code? I'll give you one last chance to scan the code. I'll move. Now everybody saw the demo, so now they're scanning. Okay, that works as well. I'll give you the instructions in a second. Your color is missing? So, combine few. Okay, so moving back, I'm going to refresh again, so we'll start from scratch. Okay, so what I'm asking you right now is to click on your favorite color, okay? And after a few seconds that you're clicking, we're going to get the favorite color here. And I'll give it 5 more seconds. I'll do 5, 4, 3, 2, 1. And the favorite and the winning color is green. Now we'll do something else. We're playing another game. And this game is basically to do what Shimon is trying to do right now, and this is to crash the stream. We'll try to increase the request per second, the vote per second, as high as we can. And what I'm asking you to do right now, and there is a prize at the end, is to click as many times as you can, and there is a winner. And you're going to see, I'm going to send the winner announcement to one of your phones. an IoT button for the winner, try to crash the system. Click as many times as you can for the next 15 seconds. Come on, you're slow. I did this in London with less people, and we got like to 170, 190. So you're not clicking fast enough. Okay, 5, 4, 3, 2, 1. Did anybody got a message on his phone? Woo! We have a winner. Magic. This is your IoT button. Enjoy. This is the old one, by the way. There is a new one, was released yesterday, so I'm giving them away. I have nothing to do with them. So let's go back to the presentation. I'll explain you what we were doing here. So this was pretty simple. I was using AWS IoT to run it, just to show you how Stream works. And in this case, I was not using Kinesis. Everything went directly to my browser, but this entire part can be replaced with Kinesis, and you can stream the data. So from one end, it's your phones, and your phones are basically getting a static website from Amazon S3. I didn't even use CloudFront in this case, although I think it's probably a good idea to do it. And in addition to that, each one of you got an ID from Amazon Cognito, so I could identify each one of you. And this is why when I announced the winner, he got the message because he clicked the most number of clicks, and I knew it by his Cognito identity, which on my management application on the right hand, I'm basically getting this information. I'm connected to the same Cognito pool, and you're sending your clicks to AWS IoT. And from AWS IoT, I can stream this data anywhere I want. As I said, I'm streaming it to my browser, so most of the calculation, most of the hard work and heavy lifting was done on my computer. But this part can be changed with any technology, any streaming technology you want to use, of course, based on Kinesis. And when I clicked on my browser, there is a shortcut for the winner, and it calculated who is the one that did the most clicks, send him the message, and that's it. So this is a very simple example to how to do some streaming. Once again, no server whatsoever, additional serverless environment or serverless service, AWS IoT Core, and everything can be done inside of that. So hope you enjoyed it. Let's move forward. So we've been talking about Firehose. Let's talk a bit about streaming data and doing real-time analytics. So there are some cases when you need to do real-time analytics on your data. For example, you have tens of thousands of sensors inside your factory in different places in the world, and those sensors are sending you temperature of the room. And each time the temperature jumps beyond a certain point, you need to send an alert to the maintenance team to go and fix the air conditioning, or to turn it on or to turn it off. First of all, you can't do this based on a single point measurement, okay? If the temperature jumped once to 45 degrees and then it's back to 28 or whatever you define as the threshold, you don't want the system to raise any events. So we have a tool called Amazon Kinesis Analytics that allow you to do analytics on the fly and basically define time window aggregation or sliding window aggregation. And you can basically say to Kinesis Analytics, take information from the last minute and calculate the temperature and the number of data sets or data points you got in this time frame, and then send it to a Lambda function that will do the math. And in case the temperature is beyond a certain point, send an alert using AWS SNS, another serverless service that will send notification, an SMS or something like that, to the maintenance team. So this is one part. The other part that I want to talk about is to talk about the Kinesis stream and how do we handle streams, and especially how do we handle very, very large streams. So if we're zooming into this part, Kinesis stream is limited to 1 megabyte per second. And if you need to process more than that, and if it sounds a lot, it's really not a lot. You're going to need to provide additional shards of Kinesis, and customers are running multiple shards to process their data. And we will create a Lambda function connected to each shard to process this data. And because there is a single Lambda function for every shard, you're basically keeping the order of your records, because there is a stream and a Lambda function that process this specific stream. When you're doing something like that, you can play with few parameters to tune your application. So for example, the number of Amazon Kinesis stream shards corresponds to the number of Lambda functions. And sometimes you would like to add additional shards if even if you're not hitting the limit, to have more Lambda invocations to process more data. From the other end, you can tune the batch size, and the batch size will basically set the number of invocation of Lambda. You can make the batch bigger or smaller depending on the number of invocation units. And this is one way to deal with large streams. Another way that Amir mentioned it today in his morning session is the fan-out pattern. And basically, a lot of Israeli companies I know are using this pattern, especially from the ad tech industry, and basically have a Lambda function that does nothing except for launching additional Lambda functions. And the idea of fan-out is to take and launch as many Lambda functions as needed to deal with your stream. What's the problem with that? You're losing the order, okay? So in case the order is not important, you can use this methodology. If you want to keep the order, so you need to tweak the number of shards, the batch size, and other parameters. I just want to give you one example about one of our customers, Reuters, is using this to run an internal analytics tool. They're usually running around 4,000 requests per second, and they're picking up to 10,000 requests. This is 25 billion requests a month. This is a very nice number of requests you need to process. They were able to create a system that takes this information and basically updates the dashboard in less than 10 seconds. From the moment they're getting the information until they can show results to their customers, their internal customers. And another very important thing regarding durability, no data lost since they launched this service. And this is something that was really, really important for them. So that was our second pattern, and just going really, really fast and talk about some additional patterns we see. So first of all, we have a lot of customers that are doing serverless data lakes, basically storing a lot of information inside S3 buckets, and then analyzing this information, doing ETLs, creating reports, and so on and so forth. And there is a very big family of products that you can use for something like that. And another very popular use case is operation automation. And this is an example of something that Capital One, one of our customers, a bank in the US, created their own internal system that basically scans every security group rule that anybody adds to the system. And if this security group rule does not fit into their own pattern, like opening RDP for the entire world, great idea, right? How much time is it going to take until somebody will hack your Windows machine? A Lambda function is basically checking every new rule. In case the rule is not according to their standards, it will delete it and send an SNS alert to the security group just for them to know who's the one to blame for opening something like that, okay? No finger pointing, but still. I prepared a list of some additional links and some additional resources that you should probably look into it if you want to use serverless applications and serverless architecture. Don't need to read it right now, but it's going to be as part of the deck. And that's it. Thank you very much.